So, good morning to all of you. We are into a new subject that is risk conscious operations management of complex engineering system. There are three terms here which need some understanding explanation. We'll understand it through as we go ahead in introduction module. There are 12 modules in which this whole course is covered, and this is the first module or first week where mostly it is introduction, background and some preliminary tools that we will be using later on in the modules, various modules will be introduced sort of. I am Professor Prabhakar V. Varde and I am CEO of a new startup, Engineering Risk Assessment and Management Center at Mumbai, and guest faculty at Luleå Technology University, Sweden, and of course I am ex-BARC, Baba Atomic Research Center. I retired in 2019 and now I am here to deliver this course on this NPTEL platform, that is National Program on Technology Enhanced Learning. So let us get going, but before that let us understand that the operations or operations management is typically a part of any industry, any financial function, any operation we do, or let's talk about complex plants which covers nuclear, aviation or process plant or safety plant. So operation form core module in all this industrial sector. The issue is here safety is of paramount importance, and that's why we require risk conscious operations management and complex system. So as we proceed, this is the first lecture. So as we proceed, I'll try to deal with these terms that we are having over here, and let us progress on this understanding this subject, risk conscious operations management of complex engineering system. Here also I take this opportunity to invite you all, whether you are in engineering profession or any other profession where you want to understand the risk. And why conscious? Because humans are the manager for everything. So risk conscious. The outline of this particular module is like this. First we will understand, introduce the topic, then operations ecosystem. Typically operation ecosystem, what is the typical features that we will try to understand, and then how reliability safety was being addressed over a period of time. So RAMS concept is called reliability, availability, maintainability and safety. Here I would only say that safety is the fourth component of RAMS. As a person who has dealt risk modeling, safety modeling and all that, I feel since we say that safety is a overriding factor, it should not be left at the fag end, number one. And when I start dealing with risk assessment, there is a popular methodology which is called probabilistic risk assessment, which provides a systematic and rational based approach for risk assessment. You might ask, PRA is a new technique. What was the earlier traditional technique? That was called deterministic technique. And let me assure you, even that traditional technique also did wonder. It got evolved over a period of time, and now with a probabilistic risk assessment, it forms a integrated risk assessment. And then risk conscious operation management is nothing but a spin-off of the risk-based engineering, a subject I have introduced, and that subject I have published a book also, and that book was published in 2018. So that will give. So my last course was on risk-based engineering, and now naturally my this area was risk conscious operation management, which is my second book. Okay, so this is how we are evolving over a period of time, and I'm trying to introduce to you this subject. And if you do these two courses, rather risk-based engineering, already it will be re-announced, and now risk-conscious operation management, probably there will be a sound understanding of safety or risk. You will be crossing into the mathematical domain, and not too much of mathematics, but of course whatever is required. Then I will demonstrate, or I will talk about this crux of this study through case studies, and then final remark. Okay, so we say complex engineering system. So simplest definition is the system which are having let us say thousands of components or millions of components, if you don't talk about the category and all that, and all the components should be healthy to serve the purpose of the intended purpose for which the system has been built. That so any system, you can say, it comprises of process systems and safety system. Safety system occupies a very significant dimension in risk modeling, and process system is basically required to run the plant smoothly and deliver its output, targeted output. Okay, and now we have got an image of nuclear system over here. Then we have a complex structure called bridge. Then the train railroad system over here, and then we have a sort of space system, then aviation, and then offshore platform, and then again we have a shipping system. There are many more. I have just given example of this, and all the systems taking care of safety is very important while meeting the designated target, like this nuclear power plant you are seeing here. The targets are for electricity generation and production and supply, and then the societal purpose are met through the bridges that are there in the public domain. Aviation, we have this transport, aviation, rail, and then road, and then and then space system, of course, and there also they have like mission like components and all that. So even though the objective is same to ensure safety and mission, but then there are slight differences when we start modeling this system. Okay, so we can see over here now, having got the idea. So what is complex system? A complex system is one which is so complex that predicting accurately the behavior is I will not say not possible, but it requires lot of understanding, lot of techniques to account for the randomness that is associated with these things. It's not that all the operations are random, but then the human factor is involved, uncertainty is there with the data, model and all, and with those uncertainty the output also will be uncertain. So randomness form the core of complex engineering system. Then they are main machine intensive actually, and then they are mega in size, so delivery also is in that size. So if the systems are down, lot of losses are made, and that way optimizing safety and reliability, they are very tricky, and they require real optimization, and the operation has to ensure both the sides to keep it safe as well as deliver the output. Okay, so now we come to the introduction. What is the deterministic approach? I told you, traditional approach for safety. Okay, defense in depth principles means one level of protection, second level of protection, third level of protection, and that way ensure that the likelihood of the accidents are very low. Conservative criteria, okay, because as I mentioned, there is a randomness with all the issues that we handle in real time. You have to be conservative. So that comes from where you have factor of safety. Then redundancy. As I told, for defense in depth is meant for multiple barrier of protection. So redundancy automatically comes into. If you require one sensor for monitoring, you have 3 sensors, and 2 out of 3 will understand those things. And if redundancy is not sufficient, you have to go for diversity. That means one system is operating on one principle, other system is operating on other principle, and they are there to meet the same objective, to protect the plant. Okay, fail-safe criteria. Even if component fails, it should go in safe manner. Okay, and then training and ergonomics. So many things are there. Especially if we talk about the nuclear energy, they have demonstrated it the safest thing. And all these principles traditionally they form of design, operation, and maintenance. Now let us see. History of accidents, whether in any domain, whether it is a transport or process or nuclear, you will see that the human factor contribution comes to 60 to 90% depending on the sector that we are talking about. So, when human factor is so important, why not we try to have enhanced understanding of human behavior, okay? And that is why human consciousness, which is fundamental to the existence. So, without that, with that gap area, whatever estimation we will do in understanding human behavior, there will be larger uncertainty compared to the hardware component. Okay. So, as such, we all admit that modeling human is a complex thing. Okay. So, this is a one stage ahead in that direction. So, make risk conscious operation management system. And what is the best way to do that? It is probabilistic risk assessment, which integrates hardware, human, and many other elements which are one-time shock and all those things. So, it provides a very good and effective platform for evaluation of safety, understanding of safety, and then documentation of safety or risk actually. Okay. So, this course, risk conscious operation management, is basically in sequel to risk based engineering. So, we will have one section in this module on risk based engineering also, because that is at the root of it, and for risk based engineering PRA is at the root of it. So, all these things we will understand in this lecture. Okay. So, let us say what is the operations ecosystem. Operation ecosystem, if you ask me, before I got introduced to the operation, what I could see, a control room. Control room which is where all the sensor signals are coming from the plant, and they are these plant areas are distributed around the main plant, or and then control room is seeing like surveillance and management is done from control room, and based on what is evolving in the plant, the operator take an action. So, you can see one operator, there are so many computer systems. Earlier there used to be hard logic and all that. Now now we have this computer based system and all that, which provides the effective information over here in the control room, so that plant safety can be ensured. So, again, the thing is, any plant and safety is an overriding factor. If we take this principle all through and and try to understand the human behavior, probably these two are central to the risk conscious operation management. Plant operation is supervised; it is 24/7 type of job, and you know that our body has got some daytime there will be some performance. Night time there will be some performance, but then the operator has to perform effectively all through the 24 hours. So, those implications are also studied in terms of human behavior in this section. Okay. And whatever the state of the art will be discussed over here. And then we have dependencies. So many systems they are operating, and then they have interconnections. So, interconnection is one of the very important factor in a complex engineering system. Okay. And then we have there is a it is but natural that there will be safety is even though overriding, but again there is a pressure of delivery also, because and it has to be it is right actually, because if my plant operates, it delivers electricity to the hospital also. In hospital patients are waiting, so we cannot say that the delivery is all that low on our optimization or operation. So this requires, that's why this requires a mathematical tool. Accident may be organized national, and once accident happens, then it has got repercussion consequences at local, city, national, international level. So, no to the accident, and so that's why I will give you a simple example. For nuclear power plant, the risk assessment shows that the probability of the core damage is less than 10⁻⁶. That means this is one level. Then they have barriers. So again factor of 10, so 10 to the minus 7. So and then finally public domain. So further it is reduced. So that is the kind of system that are built to ensure that the hazard doesn't reach in the public domain. And then training and qualification. In complex engineering system, this requires a special emphasis. That means the people who are in the job, they should be trained thoroughly and they should be performing. Their performance is being monitored, it is being checked, and so that chances of mistake can either be eliminated, but that is not possible, but significantly reduced. Okay. So, and now compared to the other plant, there is one difference between the complex system or safety plants where safety is the top criteria. They have a document called technical specification. This technical specification, it is a part of the traditional approach that it provides rules that what if anything goes wrong, what are the advices should be available, and those advices are available, or those rules are available. They are like, these rules should not be violated, tech spec criteria should not be violated. So this is basically a document which is there in control room of any plant to ensure the safety. And then it has got various things. One is the advice that if certain thing goes to certain level, plant should be shut down, or plant should be derated, or immediate action is required for tripping the plant if we are running against the time. And then for normal operation also, it provides a lot of criteria like maintenance criteria, testing criteria, and those criteria should be met. And if these criteria are violated, then it becomes a case that we have to approach regulator. So you can understanding there is always a third party or oversight that is available, which is monitoring the plant operation. So having made this, because it is built upon the concept of defense in depth. So 3-tier review and all those, they become part of this. Okay. Traditionally, the surveillance testing interval is based on experience and evidence. But then after this PRA thing, there are mathematical modules that are available. So now from traditional concepts are extended to some mathematical investigation or modeling, and then we can fine tune. So optimization can only be done when one is a judgment, another is optimization, mathematical optimization, and then it can be subjected to review, and finally result can be accepted. And that is the reason why risk has entered into. So it is a risk informed or risk based framework which is there in the most of the safety critical plants where decisions are taken, and or if decisions are not we are not able to take it, the risk insight is taken into account for finalizing the decision. So that is done at the regulator's end. And after operation, typically we will see there are operation has got two ecosystem. One is plant operation from control room and various areas. Second thing is it has got a connotation of maintenance management, and we know that maintenance become a very big subject now. So in maintenance, what type of maintenance we do? Either we do breakdown maintenance or reactive maintenance where consequences are not there at all, but then even the lowest thing we have to ensure. So there are very residual number of components are left for reactive maintenance. Mostly they are covered into the second category, that is preventive maintenance. So having said this, preventive maintenance, reactive maintenance, preventive maintenance, condition-based maintenance, and prognostics and health management is basically a new topic, and then it is still in the lab area, but as part of condition monitoring and little bit of extension, it is being used in many industries. Like in aviation, it is residual life for certain significant component, and based on the correct size, structure, this thing that is people try to understand, and they design their program. And then program of shutdown maintenance. See, maintenance management requires, there are two types of maintenance. Some jobs can be done during operation of the plant, and some job require shutdown. So shutdown maintenance, so that plant shutdown time can be reduced. So these jobs are done in operation also. So, and technical specification compliance. So even the maintenance, as I mentioned in my previous slide, we have to compliance, you have to have a compliance with the technical specification, what should be the frequency, what kind of maintenance, and how it has to be tracked and all that, And then that in maintenance, spare part control and inventory management is, so that again will come in our risk conscious operations management and logistics. There are many logistic areas which we will be talking about as and when we are discussing certain issues. Then approved procedures should be used. I mean, if you see, strictly speaking, whatever procedures are available in control room, they should be regularly updated and approved procedure, and same applies to the maintenance management also. And monitoring and surveillance, the way monitoring and surveillance is there in the operation, the same applies to areas where the equipments are operating. Areas means outside of the control room there are many areas, and there are multiple levels where the humans are manning those systems, and their monitoring and surveillance is required. And of course, root cause analysis. It is to say that this is one of the most important area. RCA is, that means root cause analysis is being performed also, it forms part of operation design maintenance. But then getting to the root of it is very important. How you will know that whether you have gone to the root of it? If you are not going to the root of it, the failure might recur, maybe at lesser frequency, but it will recur. But if you have done exact good root cause analysis, the failure frequency will reduce to a great deal actually. Okay, so now having understood this, now let us go to major elements of safety or risk conscious culture. Every plant has to have, because if it has to be reflected, one is hardware, another is if a human, then people should be aware, the operating crew should be aware, the management team should be aware of what is required for ensuring safety. And that consciousness should be there in the minds, and that should become our ecosystem. So, a risk model of the plant, it really helps you, because wherever human factors are going and entering into the risk model of the plant, we know that these are the areas and they are contributing to the top results, that is risk. So, their emphasis. So in that sense, you have found a very relevant tool for optimizing, identifying, optimizing, and seeing what has based on the importance or risk significance of the activity or actions or component, whatever. And then if I want to be more serious on this line, then I should have a human model. Don't you think it is a paradox? If we have for component, we have the model like diesel generator, then it's a cooling system, it's a shutdown system, control system, then a fuel oil system. Same in the same fashion, even human should be understood. So at present, the human model is understood in the sense of symptomatic. Training we have done, and of course that is paying the rich dividend also. But then understanding human. Why understanding human? Because in risk assessment it was found that uncertainty with human behavior is a little larger compared to the hardware. So it says directly that more, and for that we have to understand the human model. We have to have a root cause analysis for doing that. Root cause analysis is how human fails in its task and all that, and then further improvise the training. And one of the ways I can put simulator in my plant, and simulator, it provides you freedom to maneuver because there are limitations when we work on actual plants. When we go to the plant, when we are trained actually, but then in a simulator it allows you additional degree of freedom for learning and a superior methods for getting trained into the system. So what this requires is human resource and time. These are things required, finance, facility, and funding. So if that is in place, then we can do all the things well, and independent review and regulatory body is part of risk or safety culture, and more independence between facility and regulatory body, the better will be the results. So on one side we talk about safety. Safety always doesn't mean taking away time from the plant, or it's a deliverable. Major accident cause too much of unavailability. So Don't allow accident to happen. So that will happen when you ensure higher safety levels. So it is a very good trade-off between reliability and safety that goes on, and that is required also for the having a culture of risk conscious or safety conscious culture. Okay, so as I was mentioning you in this slide, I will just give you an overview of root cause analysis. So first we see that the failure event has happened, then immediate recovery is required. There is no, and then first information report. First information report is very important, because if you don't have this report, many of the information you will be missing, and then you later on they will not be available, and then assess the severity of the consequences, and based on that we have to devise what kind of root cause analysis is required. I will be introducing the idea of in my later lectures, level 1, level 2, level 3, because root cause analysis is a very time resource consuming exercise. So if the consequences are less, or penalty is less, do level 1 root cause analysis. If penalty is medium, then do level, and if suppose it is a serious nature of scenario, then go for level 3 root cause analysis. So what you will do is, it is a 6-month project. When level 1 is 15 days, 20 days, 1 month, 2 months, but level 3 analysis will be, because it is very important in India, we have to go to the real root cause and all that, and identify the root cause, and then after that feedback generation, that whether the event is repeating here. So it is a fundamental requirement for any plant, because if we don't understand the root causes of the deviation or accident, we will not be able to control the failures. So I talked about the level. The major feature of the RCAR, first is data collection. Data collection format has to be very good, and that requires interview with the staff also, because sometimes very vital inputs are available when we interact with the staff who was there when the accident took place, or manning the areas and all that, and then development of chronological order, how things have evolved over a period of time. So that mapping has to be done, and then try to assess the likelihood and consequences, maybe qualitatively or quantitatively. If we map it on a PRA model of the plant, you will have a quantified output. But every time it is not required. It is sometimes you can do qualitative analysis also, and then availability of RCA metrics. If the matrix is available, we will be able to take whether to take it to level 1, level 2, level 3, and then recommendation and follow up. Probably this is a very effective tool, and industries do follow this kind of thing. Yeah. So we talk about the accident, but then we should sometime be able to imagine if something goes wrong, what are the consequences, how our plant looks like. Probably this is one of the feedback that will if we have in our mind, probably we will become conscious of our actions, our non-actions rather, and then whatever things we have been ignoring, or normally it doesn't happen in a good safety culture this time. But then this is just one of the things that you be aware of this thing. It should be there in conscious mind. That if something goes wrong, what could be the scenario. It is just for the trying to get through the point. It is not to scare you and all that, because millions of plants are operating safely. But since this should have formed part of this thing, and this sensitization, this image has been shown. Okay. So let us see in this lecture what we have seen. We try to understand risk conscious culture. We have risk consciousness management. These are the new terms. You would have got fair idea of what this course means and all. And of course, we will be continuing with more details. Week 1 is only for introduction. Role of risk-based engineering, because risk-based engineering was my previous book, and now this is a spin-off of that book, but not less important than the original book, because operation is a huge area. Okay, and here we are able to, and variability also is more in operations. Role of human factor is very important in operation ecosystem, and related aspects like root cause analysis, safety culture, risk conscious culture. These are the things. So with this, we wind up this lecture, and in next lecture we will discuss a few more topics. Thank you very much.